Okay, hello everybody. So today we're going to continue our discussion in Chapter 2, Section 5, and I'm going to show you another type of rigid transformation. So if you recall in the last video, we discussed how to figure out a shift for a graph. Now you can either shift horizontally or you can shift vertically. Shifting was one of two types of what we call rigid transformations. Now, rigid transformations maintain the exact shape of the graph from the parent function. It does not change the shape of the graph, it just changes where the graph is located. Rigid transformations include something called reflecting. And reflecting is a very simple concept. Reflecting is if you take a graph that looks like this and you flip it over. Okay. You can also take a graph that is this way and flip it down this way. So you can reflect this way or this way. Okay. So determining which way a graph is reflected is pretty simple, although it's really easy to mix up. And even myself sometimes gets it mixed up on occasion or try to have to think about which way it's moved. But reflections happen because of multiplying by a -1. So where that -1 is within the equation is what determines whether that reflection is a what we call a reflection about the y-axis because you're spinning on the y, or a reflection on the x-axis would be this way because you're spinning on the x-axis. So where the negative is occurring is what determines whether it's a reflection about the y or a reflection about the x-axis. So, and the example that I'm going to show you is this right here. If you look at this h of x, first of all, f of x is x squared, and that is our parent function. You can see that graph right here. I'm going to highlight it with pink. So our parent function is f of x equals x squared. Now what you see right here is there is a negative. Now what you have to determine is that negative inside or outside of the function? Now this is very tricky, and it is very easily mixed up. But if you were to plug a number in for x, let's say I would put in a 2, what I want you to notice is that the negative is not being squared. Only the x is being squared. So in this case, the negative would remain on the outside after the 2 itself was squared. So because this negative is on the outside, it is not part of what's being squared, then it is going to be a reflection about the x-axis. So when the negative's on the outside, it's going to flip it on the x-axis. Now, in a similar fashion, had I had a graph that looked like this, let's call a g of x, and let's say I called it negative x the quantity squared, then that would be, because the negative is on the inside, it would reflect it about the y-axis. It would flip it over. But if you think about the parabola itself is symmetric. So if you took a parabola and you flipped it over, it's going to look exactly the same. And the math backs that up, because if you were to square this negative, that's simply going to be just x squared. So the negative on the inside really didn't matter. And graphically, when you flip it over, you get the exact same graph. Whereas in this one, the negative was on the outside. It did matter because it let our final answer be negative. So that one flipped down. So this box kind of quantifies my explanation. And what it's showing you is that a reflection about the x, which means you're spinning on the x-axis. If the negative is on the outside, it's a reflection about the x. If the negative is on the inside, it's a reflection about the y, which is spinning you this way on the y-axis. And so you can see it's a simple concept, but it's really, really easy to get the two mixed up in your head. So if I look at this now, so we're gonna do what we did similar in the last video. I'm gonna give you an equation, and we're gonna write the transformations, and then we're gonna sketch the graph of it. So the first thing we're gonna do is determine what the parent function is. The parent function, f of x, would simply be the square root of x. Okay. Now we do need to follow. If we put a number in, let's say we put 4 in for x, the first thing you would do is you would add 3 to it. So that's the first transformation that you're going to list. So that plus 3 since it's on the inside, it affects it horizontally, and it goes the opposite. So this would be a shift left 3. Remember, what am I doing? Which way? How much? So shift left 3. And then the negative on the outside, we would say we are reflecting about x-axis. So again, if I go up here real quick to this box, the negative is on the outside. It's a reflection about the x-axis. So what that means is it's going to take that graph and it's going to twirl it on the x-axis, going to flip it down. All right, so now if I were to draw my original function, the original one here is going to be just the square root of x, which starts at the origin and goes up and to the right. Okay, to shift that to the left 3 would put it right here. But now the last transformation would be the reflection. About the x-axis. So what's going to happen is that whole graph is going to flip down, and it's going to look like that. There's your reflection. Okay, and if we were to check the graph, I don't have a graph for that, but that's what it would look like if you graphed it on your graphing calculator. Okay, so we're going to try another one. I got 2 more for you. Let's take a look at this one. We have g of x equals the square root of negative x minus 4. So 2 transformations in here. Now, this is where they do really start to matter what order you list the transformations in. Again, if I put the number 4 in here, the first thing that would happen is it would become negative. So that's the first transformation we have to list. So we would say this is a reflection about, and since it's on the inside, it would be a reflection about the y-axis. And then we've got this minus 4 right here. Now, when you have a negative right here on the x, it reverses this. And this is really important. Normally, if you had a minus 4 on the inside, you would say that is a shift right 4. But because of this negative, it reverses it and it makes this shift left 4. So it actually goes the way that you would think it would normally go. Normally horizontal is the opposite, but because this negative, it made it opposite of the opposite. So it goes the right way. That's a little tricky, and that's what you got to watch with these reflections. So if I were to go ahead and draw the graph of this, I'm going to draw 3 coordinate planes just so you can see what each one of these would look like on their own. So there's the second one. Here's the third one. And when I graph this, the first graph, the parent function is just the square root of x. Now, if I reflect about the y-axis, it means I'm flipping over this way. So that's going to make the graph go like this. And then the last thing would be to shift left 4. So now my graph is going to start over there and go that way. And that would be the graph of g of x equals the square root of negative x minus 4. Okay. Now the last one I'm going to show you is this one. And you can see these negatives get really tricky because it's tricky to know whether they are inside or outside of the function. So our last one that we're going to look at, you can see, is negative and then x squared minus 3. That negative is outside of the function. And the way that you can tell that is if you had a set of parentheses, the negative would be inside. But because we don't, only the x is being squared, and then the output from that becomes negative. So again, we have to look at if we would plug a number in, what would we do first? First, we would square it. That's the function's job. And then we would make it negative. So that negative is on the outside. When it's on the outside, it is a reflection about the x-axis. And then you have your minus 3, which is also outside. That is going to be, since it's outside, it's a vertical and it is going to be a shift down 3. And again, I'm going to repeat myself. You have to have these written in the correct order, especially when you start doing the reflections. If you shift and then reflect, it will mess your graph up. You've got to have them listed in the correct order and do the transformations in the correct order. That's why I'm showing you these in stages. So the first thing we're going to do is look at the parent function. The parent function of x squared is simply a parabola, just like that. If we reflected it at about the x-axis, here's the x-axis. If we flip it, we're flipping it this way. That means it's going to flip that parabola upside down. Okay? And that's actually something that you guys already knew previous. If that lead coefficient is negative, the parabola is going to face down. Now, the last thing to look at is we need to shift that down 3, which would then put me right here. So it stays upside down and then it shifts down 3. And there is our final sketch of what that would look like. So hopefully that made sense to you. And so the next video, we will be talking about non-rigid transformations. But for now, we're still maintaining the shape of the original graph. And so if you guys have any questions, as always, feel free to email me. Have a great day.